the reader's writer's problem. So in this problem, there are certain processes, we call them as readers that only read the shared data and they will never change it. And there are certain other processes, we will call them as writers, who may change the data in addition to reading. That is, instead of reading it, they may change also. So there are certain types of reader-writer problem, and they are mostly centered on relative priorities of readers and writers. So we'll again state the problem. It is again reader-writer problem or readers-writers problem. It is a classical again example of classical synchronization problem. So there are many variants of this problem. Let us see one of them. Problem statement is like this. There is a shared resource which should be accessed by multiple resources. So we have a shared resource to be accessed by multiple processes. There are two types of processes in this context. One is your reader and say this is the writer. So any number of readers can read from the shared resource simultaneously. That is, these two readers can read easily, but only one writer can write on the shared resource. So when a writer is writing data on this resource, no other process can access this resource. So it has to be logged at that time. So writer cannot write on the resource if there are non-zero numbers of readers accessing the resource. That means if this or any number of readers are accessing it, writers should not access it, because writer may be changing, the reader may be getting some inconsistent data. How to solve this? This statement we have just seen. From this it is quite evident that readers have higher priority than the writers. So if a writer needs to write to the resource, it must wait until there are no readers currently accessing or reading that resource. So we use one mutex M and a semaphore W. Mutex M and semaphore W. An integer variable read underscore count. This is used to maintain the number of readers which are currently accessing the resource. So read underscore count are how many readers are accessing right now, and the variable read count is initialized to 0. A value of 1 is given initially to this M mutex M and semaphore W. So instead of having the process to acquire a lock on this shared resource, we can use the mutex M to make the process to acquire and release lock whenever it is updating the read count variable. The code of the writer is like this. Writer would only write when no reader is reading. So writer will wait. This W is what? Semaphore W. It will wait. Then it will perform the action, that is perform the write action, and then it will signal that okay, wait means it's kind of holding a lock only, and this signal means okay, I am done. And the code of writer as we have just seen, and this is the code of the reader. So what reader is doing? Reader is waiting here to acquire a lock. Then because reader will increase, many readers can read simultaneously. So if read count is equal to 1, if read count is 1, then it has to wait W, then signal, that is it has to release the lock, perform the reading operation, then again wait, it acquire the lock, then read count has to be decreased, and if read count equal to 0, then signal okay, read count is 0, and signal M, that is the M we have just seen mutex. Let me again describe you or explain you this code. This is very important. See here, the writer just wait. First of all, this W is the semaphore. This is a semaphore. So the writer just wait on this W semaphore until it gets a chance to write the resource. After performing this write operation, it increments the W so that the next writer can access the resource. If you see the reader one, the lock is acquired when the read count is updated by the process. Okay, this is the acquire lock. This is the acquire lock, and this lock is acquired when read count is updated by the process here. So when a reader wants to access the resource, first it has to increment the read count. That is how it has to increase because he is also the reader is reading. Then he has to access the resource, and then after that decrement the read count value. So it has to decrement also. The semaphore W is used by the first reader. This is the first reader, right? Which enters the critical section, and the last reader will exit the critical section. The reason for this, why this has to happen, when the first reader is entering the critical section, the writer has to be blocked from the resource. Only new readers can access the resource now. No writer. In the similar fashion, the last reader exits when he exits the critical section. It has to signal the writer using the W semaphore because there are 0 readers now. There are no readers. Now writer can get a chance to access the resource and can change it. This is how. So this is a very short idea about the readers writers problem. Thank you so much. Take care of yourself.